Agriculture is our wisest pursuit because it will end to contribute most to the real wealth and happiness. Good day everyone, we are Group 3 and today we will guide you to the beauty of organized farming. In this video, we will explore 3 important planting patterns used in agriculture. The square patterns, the king counts or diagonal patterns, and the triangular pattern. Each of us will clearly explain their layout, advantages and disadvantages, suitable crops and simple computations so that everything will be easy to understand. So, let's begin our journey into smarter planting.
Let's start with something simple and easy to imagine. Picture this as a board where every piece is every species. That is how the square patterns work in the system. Crops are planted at equal distance, both between rows and between plants, forming perfect squares. The layout makes this field look neat and organized with straight lines going through both vertically and horizontally. It is the one of the simplest and most commonly used planting system in the agriculture.
One advantage of the square pattern is very easy to manage. Farmer can easily move between rows for watering, fertilizing, and harvesting. It also allows equal distribution of sunlight, air, and nutrients, helping plants grow uniformly. Another advantage is that machines or tools can be used more easily because of the straight alignment of plants. Even though it is simple, the square pattern has some disadvantage. It does not fully maximize the use of land because there are open space between plants. This space may also allow weeds to grow if not controlled.
This pattern is suitable for crops like mango, coconut, and papaya, which need enough space to grow properly and develop strong roots. At this point, we have square pattern computations formula, which is population density equals area of the farm square meter divided by plantings distance square meter. For example, we have the farm area of 10,000 square meters and planting distance of 5 meters to compute the population density. We first identify the total area of the farm, which is 10,000 square meters. Next is we look at the planting distance, which is 5 meters. This means each plant occupies an area of 25 square meters because 5 meters is multiplied by itself, which is 5 meters is equal to 25 square meters. After that, we have divided the total farm area by the area occupied by one plant. So 10,000 square meter divided by 25 square meters is equal to 400. Therefore, the plant's population is 400 lanzones trees in 1 hectare. This means that if we follow a 5 meter spacing, the land can accommodate 400 lanzones tree efficiently without overcrowding.
The quincunx pattern, also known as the diagonal pattern, is similar to the square pattern but with one additional plant placed in the middle of its square. This center plant is usually temporary, making the field look fuller and more productive at the early stage.
The advantage of this pattern is that it increases the number of plants per area, which means higher early income for farmers. However, the disadvantage is that it can cause overcrowding if not managed well. The temporary plants may compete for nutrients, sunlight, and water, which can affect the growth of the maintained crop.
This pattern is commonly used for fruit trees like mango and coconut, with banana or papaya. As a temporary filler crops, at this point, we have our quincunx patterns computation formula, which is population density equals area of the farm, square meters divided by planting distance, square meter plus length divided by planting distance minus 1, and wide divided by planting distance minus 1. For example, given a farm area of 10,000 square meters, which is with a planting distance of 10 meters, we first solve for the square pattern as our base computation. Since 10 meters is multiplied by itself, which is 10 meters square, at 100 square meters, each plant is the square patterns occupies 100 square meters of space. Next, we determine how many plants can fit in the field using the square fit patterns. We divide 10,000 by 100, which equals 100 plants per hectare. However, since we are using the quincunx or diagonal patterns, we add additional additionally plants in the center of each square to maximize the use of space. First, we compute the number of plants along the length. We divided the length of 100 meters by the planting distance of 10 meters, which gives 10. Then we subtract 1. So, 10 minus 1 is equal to 9. Next, we do the same for the wide. We divide 100 meters by 10 meters, which also gives 10. That subtracts 1, resulting in 9. After that, we multiply the two results. 9 multiplied by 9 equals 81. Additional center plants, we also compute the square patterns population first. Since 100 divided by 10 equals 10 for both length and wide, we multiply 10 by 10, which gives 100 plants. Then we add them together. 100 square patterns plants plus 81 center plants equals 181 rambutan trees per hectare. This shows that the quincunx pattern increased plant population by adding extra plants in the center space, making better use of the land compared to the square pattern.
Triangular pattern. Let's now look a more advanced and space-efficient system. The triangular pattern arranges plants in a way that forms triangle instead of squares. Each row is slightly offset, allowing plants to fit between others. This creates zigzag arrangement that maximize the use of land. The main advantage of the triangular pattern is that it allows more plants to be grown in the same area compared to the square pattern. It also provides better sunlight distribution. However, the disadvantage is more difficult to lay out and requires careful measurement. Farm operations like plowing and irrigation may also be harder due to zigzag arrangement.
This pattern is suitable for crops like coconut and mango, especially in large plantation. At this point, we have a triangular pattern. Computation formula, which is population density equals area of the farm square meter divided by planting distance square meter times 0.866. For example, we have the farm area of 5,000 square meters and planting distance of 4 meters. So to compute the population density for a triangular or hexagonal planting pattern, we first identify the total area, which is 5,000 square meters. The planting distance is 4 meters. So we square it first. 4 squared is equal to 16 square meters, which represents the area occupied by each plant in a square layout. However, since this is a triangle pattern, we adjust the formula by multiplying 16 square meters by 0.866. This is factors is used because the triangular pattern allows more efficient use to space compared to the square pattern. So 16 square meters multiplied by 0.866 equals 13.856 square meters per plant. Next, we divide the total farm area by this value. So 5,000 divided by 13.856 give approximately 360.85. We round it down to 360 banana plants. This means that using a 4 meter spacing and triangular pattern, the farm can accommodate around 360 banana plants and 5,000 square meters of land.
The future of farming depends not only on hard work, but also on smart planning. Planting patterns play a very important role in agriculture. By choosing the right system, whether it's square pattern, quincunx, or triangular pattern, farmers can improve productivity, manage their crops better, and make the most of their land. Thank you.